Hi, Chuck Huber here for the Stata YouTube channel. Today I'd like to show you another new feature in Stata 16, Bayesian predictions. Bayesian predictions are useful for forecasting, model checking, building optimal classifiers, imputing missing data, and many other things. We can use Bayesian predictions to simulate outcomes from the posterior predictive distribution. We can also simulate functions of simulated outcomes, generate replicated outcomes, and calculate posterior summaries of simulated outcomes, as well as posterior predictive p-values. There are three new commands that can be used for Bayesian predictions: Bayes predict, Bayes reps, and Bayes stats p-values. Unlike classical predictions, Bayesian predictions generate multiple MCMC values for each observation. So for example, if we were using the auto data set and we wanted to compute Bayesian predictions for miles per gallon, we will obtain 1,000 or 10,000 or whatever simulated values for each of the 74 observations in the data set. We can then calculate summaries such as a posterior mean or a median, which would produce one value for each observation. Then we can compute posterior summaries for the variable of interest. So let's take a look at a quick example. Here I'm going to open the auto data set, and then I'm going to use the Bayes MH command to fit a linear regression model where MPG, or miles per gallon, is the dependent variable, and then the weight of the car and the length of the car are covariates in my model. So let's execute this. And here I can see my results of my model in the results window. I can calculate my posterior predictions by going to Statistics and scrolling down to Bayesian Analysis and then selecting Predictions. And this will open the Bayes Predict dialog box. I can calculate lots of things. I want to begin by computing posterior summaries of simulated outcomes. So I'm going to select this. And this will allow me to compute posterior means, posterior medians, posterior standard deviations, or credible intervals. So I'm going to compute a posterior mean. I need to give my new variable a name, and I'm going to call it MPG PR for predicted MPG. And I want to do this for the outcome variable MPG. I only have one outcome variable, so I only need one. And I'm going to click OK, and this will issue the command Bayes predict MPG PR, and I'm calculating the mean, and then the outcome variable is MPG. So now, if I list any variables beginning with MPG, that's what the MPG star means, in the first 10 observations, I can see MPG is the original observation for miles per gallon, and MPG PR is the posterior predictive mean for MPG for my model. Now another thing I can do, if I go back to my dialog box, is I can generate MCMC replicates of simulated outcomes. So I'm going to change my new variable name. This is actually a stub, so I need to put a star at the end because it's going to number these for each of the replicates. I want to generate 3 MCMC replicates, so I'm going to change this to 3, and again I want to do this for the outcome variable MPG. So I'm going to click OK. And now, if I list, I'm just going to scroll up here, if I list everything beginning with MPG in the first 10 observations, again I see my observed values for MPG, my posterior predicted mean, and then I also see 3 replicates. So these are generating replicates for each of the predictions, and then the mean averages over all of those replicates. And typically we would do this for something more like 5 or 10,000 replicates, but here we could just do this for 3 and see them in our data set. So we probably don't want to add 10,000 replicates to our data set, but we can actually create 10,000 replicates and save them to a separate data set. And we can do that again using Bayes predict. So I'm going to go back to Statistics and Bayesian Analysis and go back to the Predictions dialog box. So at the top here we see Compute Bayesian Predictions, and we're going to simulate outcomes for selected outcome variable and observations. So the first thing I need to do here is click Create, and it's already selected the outcome variable for me, MPG, so I'm going to click OK. And then I will need to save my predictions to an external file, and I'm going to name that MPGPR, and that will save my predictions. And just in case I've run this before, I'm going to select Overwrite File if it already exists. And now I'm going to click OK, and the dialog box issues the command Bayes predict. It generates _YSIM1 for me, and then it saves the replicates to a file called mpgpr, which we'll come back to shortly. So now if I want to see summary statistics, I can go to Statistics, back to Bayesian Analysis, and I'm going to find Summary Statistics. This will open the Bayes Stats Summary dialog box. And I'd like to see summary statistics for Bayesian predictions, so I'm going to select that. And then I need to specify the data set, so I can either browse to that, but I know I named it MPGPR. And then press Create. And I want to see the simulated outcomes, and I'm going to click OK. And then OK again. And now I can see the posterior summaries of Bayesian predictions for each observation. So for observation 1, if we scroll back, we'd see that the observation was equal to 22. The mean of those 1,000 replicates is 21.88691. And we see a standard deviation and an Monte Carlo standard error, median, as well as an equal-tailed credible interval for those. Actually, this is 1,000 MCMC sample size. So this is the mean of those 1,000 replicates for observation 1, and we have the mean for observation 2 and observation 3 all the way to observation 74. Now, another thing that I can do is calculate Bayesian posterior predictive p-values. So I'm going to go to Statistics and scroll back down to Bayesian Analysis, and then I'm going to select posterior predictive p-values. And I need to specify the data set where I saved the replicates. So I'm just going to type mpgpr, that's where I saved the data. And then I'm going to click Create. And I have some options here. I can do posterior predictive summaries for replicated outcomes, residuals, and more, or expressions of replicated outcomes, residuals, and more, or functions of them. So I'm going to select functions, and I'm going to give this a label. I'm going to call it ymin. And then the function name, I'm just going to type minimum, or min. You can use any meta function that you like here. So then I'm going to click OK. And let's see. I will just do that and leave everything at the default and click OK. And this issues the command Bayes stats p-values, and this is for the minimum value of MPG. So if I look at my output here, I see a posterior mean and a posterior standard deviation, and this is for the minimum. Okay, so the observed minimum in our data set is 12, and in our replicates, we observe a posterior predictive mean of 7.7. And so what this is showing is this probability at on the far right column is the probability that the test statistic in the replicated data is as or more extreme than the test statistic in the observed data. And so Bayes stats p-values is often used to assess the goodness of fit of a model. So I keep referring to these replicates. I just want to show them to you very quickly. I'm going to type use mpgpr. I need to clear the data. And this will open our actual data set that contains the replicates. So I'm going to browse the data here. Now each of the observations, we had 74 observations in the auto data set. And so we have 74 columns. The actual observations are now columns, and then the rows are the replicates, the MCMC replicates here. So that's what the data look like if you were to open this file. It's a fairly large file. If you'd like to learn more about Bayesian predictions in Stata 16, you can visit our website and download the manual. I hope this was helpful. Thanks for stopping by.